Anything else? Okay, so then can we go back to chapter 5? So we said that number 1, I'm going to post something from last semester. Number 2, we have test 3 on May the 3rd. Let's say, I don't know, 1:30 to 4, 1:45 to 4, something like that. Okay. And please stop me if you remember anything, if you have any questions. So I'd like to go back to, let me see if I have a pencil here. I do. I'd like to go back to 5.1 and give another example. Brian was, yes. Brian asked last time, okay, this is wonderful, but where is it used? And I'm trying to show you as many examples with what we are doing is applicable. So here is a problem, problem 17 on page 370. So I don't know if you can see, maybe I can raise the book a little bit. Maybe if I do this. Is this a little better? So the velocity graph of a braking car is shown. Use it to estimate the distance traveled by the car while the brakes are applied. So since this is a velocity and we want to determine the distance is the antiderivative of the velocity. So between 0 seconds and 6 seconds, all I have to do is determine this area. And that will give us the total distance covered between 0 and 6 seconds till the car comes to, to a stop, velocity 0. From velocity 60 something, maybe even 70 miles per hour to 0, what would be the distance? So the antiderivative, we don't have it because we cannot determine the antiderivative. We are not given the function. We are only given the graph. So I would have to estimate. Of course, it's going to be a rough estimate because I don't know how accurate I can determine this area under the graph. So this is 1, and this is 3, and this is 5. So I'm going to try to estimate this area. I'm going to use the midpoint if I can for each subinterval because I know the midpoint is the best. So this will be one area. This will be the second rectangle. This will be the third. This will be the fourth. Then the next. And then the next. I estimate that this, of course, the width of each subinterval is 1. So I don't even have to worry about that. So the height here, I'm going to say, it's not exactly in the middle, but I'll estimate it as being 50. So this is 50. I'm going to write it down on a piece of paper and then copy it for you. Then this one is 40. This one, maybe I'm going to say 30, is not exactly. This one, I cannot say 20, I'm going to say maybe 17. And this one, if this is 10, maybe 10. And for this one, the height, it's maybe 2. So I estimated the distance needed by the car driving at roughly 70 miles an hour. So this was problem 17. on page 370. And the distance, I added up 50 to 40 to 30 to 17 to 10 and to 2. They're all multiplied by 1. So what do I get? This is 100. This is 147.49. And that's feet. Just making sure feet per second, feet, yes. So this is another application of the antiderivative, but in this case I can determine it. And I can't, since I don't have the velocity and I cannot plug in those numbers, I can only estimate. Any questions? Any questions? So that was another application of the antiderivative, which is the same thing, the same application with the definite integral, but we haven't gotten there yet. Okay. I would like to look at some more applications. If you'd like to choose another cubic, linear, we've done that. Another quadratic or cubic function. Please choose an interval, and let's determine the area under the graph. Before we look at properties, and before I explain what the integral is again. Would you like to choose a function?
I got between 1 and 4.
1 and 4. And we have to decide on a function.
Maybe something like x cubed plus 27, or I don't know.
That's fine with x cubed. It's gonna take a long time, however, because when you find xi, it will be 1 plus 3i over n, and we will have to cube that. That's fine. It's up to you. You choose any function you want.
Maybe you do one. I'm not sure.
We can use a quadratic. We can use a quadratic. So what I was going to say is that the area could be positive or negative. I would like you to keep that in mind. So for example, in this situation, I just have it open. So this area is definitely smaller than that, so the result will be positive. If we want to determine the area between 0 and 3 under the graph, we're going to have a little negative piece and a bigger positive piece. But however, here, for this example, this will be a much bigger piece that is negative than this piece. So the answer for this will be a negative answer. So don't get scared, it's possible. So whatever you pick, just remember, I just wanted to show something like this. So this area is negative, this area is positive. Obviously between 0 and let's say and 10, the result will be negative, because this is much smaller than that in absolute value. So now let's choose. We can choose a quadratic function. If you'd like. We can choose a cubic function, it doesn't matter. I just would like to practice before we move on and explain what the definite integral is and go through its properties. Okay, I'm going to pick a problem from your text then. Let's say from 1 to 4, problem 22, but it's a different technique because we haven't discussed that technique yet. So I'm just copying the function from 22 on page 383. I'm just copying the function, but we're doing something else. we're going to apply that technique later, hopefully today. Okay, so we have the interval between 1 and 4. We're asked to find the area under the graph of x squared minus 4x plus 2 between 1 and 4. If you remember from last time, I know you haven't gotten the chance to look at this too much, but there are 3 preps, mandatory preps, before we put everything together to determine the limit of the Riemann sum. The first prep is delta x. Delta x, by definition, for the interval a comma b, is b minus a over n. Remember, we always have n subintervals, and n eventually will go to infinity when we write the limit. But remember, n subintervals. So in order to divide the interval by n, I have to have b minus a divided by n. That's the width of each subinterval. So in our case, will be 4 minus 1 divided by n. In other words, 3 divided by n. This is the width of each subinterval. This is the width of 3 over n, 3 over n, 3 over n, and so on and so forth. Now we need to find xi. Xi, by definition, is always a, whatever that is, the left point, the endpoint, the left endpoint of the interval, plus I delta x. This is the definition, where a in our case is 1, I is I. This is 1, 2, 3, dot, 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 I. So a 1 plus I delta x will be 3i over n. Next, we have to find f of xi. So in our function, where I see x, I will replace it, the x, by 1 plus 3i over n. So this is f of 1 plus 3i over n. So then, 1 plus 3i over n, everything squared, minus 4, 1 plus 3i over n plus 2. You understand that that's one technique. If you find another technique that works for you, please use it. I prefer simplifying this to the fullest before I put it in the limit of the Riemann sum. So when I square a binomial, I get 3 terms. The first term squared plus 2 times the first times the second, plus the second term squared. I distribute -4. I clean it up and put it in descending order. This goes in first. Now these two, minus 6i over n. And then -4 plus 3 is -1. Any questions? Any questions? Okay, so now I'm ready to write the exact area as the limit as n approaches infinity from the sum from I equals 1 till the last subinterval, and n goes to infinity, from delta x times f of xi. This is the formula, this is the definition, this is the exact area. Okay, so I will plug in. I just put my pages aside. So I have delta x, which is 3 over n. This will be 3 over n. I have f of xi, which is right here. 9i squared over n squared minus 6i over n minus 1. And now I'm going to apply a few properties of the summation notation. I equals 1 through n. This does not depend on I. This is a constant. So limit as n approaches infinity from 3 over n. There is a second property that I will apply, which is the sum of this minus this minus this is the sum of the first term minus the sum of the second term minus the sum of the last term. We're not distributing. This is just a property. So the sum of 9i squared over n squared minus the sum of 6i over n minus the sum of 1. They're all from I equals 1 through n. Is this okay? Any questions? Any questions? Okay, so then we continue. My next step is to realize that there is a constant here that multiplies I squared, will go out. There is a constant here that multiplies I and will go out. So this is limit n approaches infinity 3 over n, 9 over n squared, the sum of I squared, minus 6 over n, the sum of I, and I can already replace this by n from last time. Of course, from I equals 1 through n. Oops. So now this gets replaced, and this gets replaced. This one is the ugly one. N plus 1, 2n plus 1 over 6. This one is n plus 1 over 2. At this stage, I got rid of all the summation notations, but I just have to rewrite everything. So this is limit as n approaches infinity from 3 over n, 9 over n squared times n plus 1, 2n plus 1 divided by 6 minus 6 over n times n plus 1 divided by 2 and minus n. So at this stage, I see that the summation notation is gone. And that's what I wanted to accomplish at this stage, in this step. Next, I'm going to try and simplify as much as I can. So I'll simplify by n. I could simplify by 3 here, and the denominator is 2n here, that's fine, I love that. 6 divided by 3 is 2, and 9 divided by 3 is 3. So then I have limit as n approaches infinity from 3 over n. I realize that the least common denominator will be 2n. This is over 1, that's why it needs to be multiplied by 2n. So let's see what we have. I have to distribute 3 to these two, but I have to multiply them first. So I have 3, 2n squared, plus 2n plus n is plus 3n and plus 1. Then I have, there is no need to simplify here because you need the least common denominator to be 2n. So minus 6n squared minus 6n, and of course minus 2n squared. Any questions so far? Can simplify anything? We have to wait so we can combine like terms, etc., etc. Limit as n approaches infinity, the denominator is 2n squared. So 3 is outside this 3, and now let's see what I get. 3n squared, oh nice, minus 6n squared is gone. 6n squared minus 6n squared. 6n squared, 6n gone. So these two are gone. 3 times, so there is a negative 2n squared. 3 times 3 is 9n minus 6n plus 3n, and 3 times 1 is 3. I'm checking my work. That's okay. This is 6. This is 9 minus 6 is 3, and this is 3. Yes. I already know the answer, but let's say we don't. So limit as n approaches infinity, minus 6n squared plus 9n plus 9 divided by 2n squared. I see it's infinity over infinity, L'Hopital's rule. Although, as I said, we know the answer. So negative 12n plus 9 over 4n. Again, L'Hopital's rule. Limit as n approaches infinity. Negative 12 over 4, which is negative 3, which we knew from here. Negative 6 divided by 2 is negative 3. So it happened that in this particular situation, the area is negative. Any questions?